Both myself, Brendan, Roch, we very frequently engage in customer performance escalations when a customer is dissatisfied with the performance of their Oracle technology, and they make some phone calls and they call us in. And so we wanted to talk about some of the common issues we run into, the pitfalls, the mistakes that we see across a fair number of these customer performance escalations, and basically educate folks so we can get a much smoother and more efficient path to root cause, right? And so one of the bigger things that I tend to run into is the not a problem problem, right? Where the problem definition that comes in from the performance escalation is not a real business level performance metric, meaning I should be getting 200 transactions per minute, but I'm only getting 5 minutes, but it takes an hour. Those are real performance metrics. Right. But rather what we get is my CPUs are 80% utilized, or 90% utilized, or 100% utilized. So what's your performance problem? Oh, well, that is my problem, right? Or as you said, Roch, I only have 4 gigabytes of free memory on my 64 gig machine.
What's the problem?
What's the problem?
I don't have a problem.
Right. So one of the bigger not a problem issues we run into across a variety of escalations is simply the lack of a clear, concise, crisp problem definition. Something related to what the workload is doing, something related to the business that the workload is supporting, and more importantly, something that we can measure. Something that we can measure so we can figure out, A, is it what you say it is, and B, if we make a change, did we make it better? Did we not change it, or did we make it worse? Go ahead, Brendan.
One general rule that I use is the customer talking in terms of latency that the client experiences? If the client is experiencing latency, that's a problem. If they're trying to do an application and they're stalling, that's a problem. If they're talking in terms of IOPS or CPU % utilization, that may or may not be a problem. So to get our attention quicker, and this is a good topic because most of the performance problems that I get escalated to me turn out not to be a problem, turn out to be this type that Jim's talking about, where they've looked at a statistic and misinterpreted, thinking that they've got a problem. So to help you out, look for latency. I'd say latency is a very good one to start with.
Oh, absolutely.
And I'd say before that, right, you really, you're talking to the people that are let's say, on the first line with a customer. The customer has a complaint. And the range of complaints are very different in range. They're different in what went into the complaint. So you really have to put that into the initial queries is, what is the nature of the complaint? Is it, very often we're going to get something which is, hey, the system feels slow. And can you help us out? There's not enough data here to know what it means, because feel slow can be a 5% degradation over yesterday. It can be a 5,000% degradation, right? You got to put more words into describing what is the problem. How is it impacting businesses? You did mention, for instance, sometimes it's CPU utilization has gone too high, and techos like us will say, what's your problem? And if it's stated up front that we have an SLA with this kind of environment that mentions that we cannot go over 80%, and then that changes the conversation. Okay, so you do have that problem, right? But how did you get there? That's a very important. We were there yesterday. We were at 60. Today we are at 90. What changed, etc. You really have to provide information up front.
You have to have the
describe more the problem, and feel slow is sometimes the only thing that you have, but you got to try and characterize it better in terms of yesterday I did something, I didn't notice anything, and today I'm doing LS, it's taking a minute. That is a feel slow, but if we get that written up, it really helps us.
And it's something you can measure. You can measure LS is taking a minute, and then you can measure if you've made it better or worse.
Yes.
Right.
Yes.
So it's plus you also need to have those conversations in order to define the path to root cause, right, and make sure everybody's moving in, moving in the same direction. If it starts off as, well, I just received a compressed tar file in my inbox, and it's the output of MP-stat and SAR and IOStat and NetStat and VMstat all collected over the last half hour or hour, and I get a bit of this, and so I have a bunch of system statistics in front of me, but I don't even know what the workload is. I have no performance problem statement that tells me, well, this is running, an Oracle database, or it's running a web server, or it's running an app server. No performance metrics related to what the workload is doing. Just a bunch of system statistics, and that's, it's not going to get you anywhere.
And if I get these customers on the phone, and I think this is basic troubleshooting as well. Some of the early questions I'll ask is, what makes you think there is a problem? So that we can find out if they can express it in terms of latency, or if they're looking at some statistic they may not understand. We'll also ask things like, what changed recently? Has this ever worked?
Right. Yeah. So, kind of going from top to bottom on some of our favorites, CPU utilization floats to the top all the time.
So so why isn't high, so if we're explaining this to something, why isn't high CPU utilization a problem? Shouldn't I have a lot of headroom?
And the answer is no, not anymore.
You might have headroom even if you're 100% busy.
Yeah, you might, exactly right. The whole CPU utilization thing, it goes back to the early compute days of the 60s and mainframes, and CPUs being very, very simple beasts. And I mean, I started with CPU utilization, but it really applies to anything, whether you're looking at a CPU or an HBA or a NIC or whatever. What does it really mean to be 100% utilized? Mm-hmm. It simply means that every time I went to look for work to do, there was work for me to do. It doesn't mean that I'm not capable of doing more work and still meet performance levels.
You're busy 100% of the time, you're not saturated.
Yeah, maybe my job is to move this boxes from over here to over here, so every time I turn to my right, there's a box there for me to move. But somebody could stack 4 boxes, and so I could get more work done. It's kind of an ugly metaphor, but it works.
And specifically with high CPU utilization, if a request comes in and the CPUs are busy, that may get dispatched maybe a millisecond later than usual. That CPU dispatch latency time may be drowned out by all the other latencies as part of that IO transaction.
Yeah.
So actually waiting for an available CPU core may not matter at all.
Yep.
That's right.
So you mentioned disk IOPS also as a common...
Disk IOPS as well. People look at the disk rates and say, my disks are doing 110 IOPS, surely they're maxed out.
Right.
Why that isn't a problem, I can start this, is firstly, if a disk is doing 110 IOPS, that may be random, that may be sequential. 110 IOPS, say on a 7200 RPM disk of random IO, may make that disk 100% busy. That could be a problem. If it's sequential, the disk may only be 20% busy, may even be less busy. So IOPS directly is not a good measurement if there's a problem, because you don't know whether they're random IOPS or sequential IOPS, and that makes a big difference. The second thing I'd say about this is some disk IOPS don't matter at all. So if I'm writing to a file system and it's flushing asynchronously to my application, it may be dumping out huge amounts of content to disk. That might be queuing up. The performance of that might not look great when you start analyzing it, but it doesn't actually matter to your application. That's an
because that's all happening asynchronously to the application that's issuing the disk reads and writes.
That's right.
So the application is moving forward. Its system calls have returned, and all this stuff is going on in the background.
And like in ZFS, right? A lot of people have focused on, let's say, the IOStat latency and service time.
Right.
And it turns out that the service times don't differentiate between reads and writes.
Yes. And
with ZFS transaction group mechanism, the service times that you're going to see from IOStat are going to be governed by the write, which are time. There's a queue of them that explains why the service times are high. And you're really interested in read service time, and you're interested in write bandwidth. And these are things that don't necessarily come out of the IO.
And again, that's because in a typical ZFS environment, this stuff is all happening asynchronously to the application code that issued the IO.
Yeah, so we're really looking for synchronous latency, and that's the identifier of a problem.
Right.
Reads are usually synchronous because the application has requested something and is waiting for that to return. Writes are usually not synchronous because you write to DRAM, it uses that as a buffer and then flushes it out later, unless you're doing a synchronous write. So as you said, IOStat bundles them together, the latency that matters and the latency that doesn't matter. And so some people think there's a problem with ZFS, when in fact it doesn't actually matter. That high latency is not experienced by the client.
Absolutely.
Right, so there's the There's the general issue of decoupling some of the latency measurements you get from the system tools to what is actually really inducing latency at the application level.
And of course, dtrace is great at this. I'm sure I've got examples in the dtrace toolkit for it. For the Oracle Sun storage appliances, we do have analytics, which lets you separate them out as well, so that you can look at the read latency versus the write latency.
The latency to the write SSDs, for instance.
Yes, that's right.
Absolutely. So the write latency to the write SSDs and read latency from read SSDs are really what you're interested in, what your cache hit rates, etc.
Yeah. So let's talk about the memory thing for a minute, then we'll go on to networking, because the memory comes up a lot, and it comes up a lot in several contexts. One of the more common contexts is my free memory is really, really low, and I'm worried about that, relative to the total amount of memory installed on the system. And then one of the other common things we run into is people use, PS or PR stat or one of the tools that give you the amount of memory per process, physical memory per process, and they do the math, and it's 2x or 3x or 10x the amount of RAM they have installed on the machine, and they don't understand that. So first on, maybe we should start just talking about the free memory side. And
sometimes it's low, and that's not a problem. Sometimes it's high, and that's a problem. So I've seen quite a few examples recently of people with high free memory, and they're going to say, well, I'm going to remove memory boards. And even when you have free memory, it's still used for caching in different layers by file system.
That's right.
And so having a lot of free memory in Solaris doesn't imply that it's not in use.
Yes.
And having low free memory doesn't imply that it is not available to other applications. By the means of memory pressure, ZFS will respond to pressure and return memory. And then a lot of people, have faulted ZFS for consuming all of the memory. And it actually, there were, stuff that has been fixed since, and a lot of stuff where you are returning the memory to the application so that it can use.
Yeah.
So either way, it's not necessarily a problem. You gotta have a better look at the specifics of the situation.
That's right. And the overall principle is for Solaris, if there's available memory, use it for something useful.
Absolutely.
So Solaris will fill up the DRAM that you have for file system caching or whatever, because it's useful. And that's the easiest way I tell customers to improve performance on systems. Usually, buy more DRAM.
Sure.
And we've been saying that for a long time. It's still true.
it is still true.
Buy more DRAM because they can cache and improve performance.
And then the good news is too that with the tools that we bundle in with Solaris, it's actually pretty easy to figure out if waiting for memory is inducing latency on your application, which is really the only thing you care about, right? Am I sitting here blocked in page faults? Am I waiting for memory?
So how do you do that?
PR stat, microstates. There's actually PR stat, microstate, DFL and TFL makes it very, very easy. If those values, text fault or data fault are non-zero, then that's a percentage of time those threads we're waiting on that, and it just, you don't even need to use dtrace, but you can use dtrace too if you want to measure it, empirically with finer granularity. So, but it's actually just as an aside, because we do between the three of us, we probably talk to a lot of customers. Performance problems that root cause to memory issues are very, very, very rare, in my experience. I mean, most customers have sufficient memory. A lot of the escalations that come in that are memory related are perception / expectation, or not understanding the metric properly.
We also jump into conclusions about it. I think it's that human nature. You've got something, you look at it, and you go where you're familiar. A lot of performance problems, right, that are, let's say, looking at the 7,000 storage, end up in the network, on the client side. I mean, we live in a complex world. The performance is global, systemic, right? And you need to look at everything. And response time, is going to depend on the inject time or the number of requests that are being injected in the system, etc. It's all linked in. And if you focus too quickly, and I think we all do that, so you got to step back at times and really ask yourself, why do I think that there's a problem in this area?
But I am very sympathetic to the situation. If I'm learning performance and I so you go into an internet search and try and read things. A lot of the documentation out there, pretty early on, will refer you to VMstat.
Yeah, that's
And
true.
so VMstat leads you into examining memory, but
Right.
also VMstat was designed in the 80s. You're looking at scan rate from the page scanner.
Right.
It's really a blast from back in time, and so that's quite confusing for a customer. VMstat, I guess ideally we would re-whack it and change the columns. So for example, VMstat hasn't been designed really to show you what's happening with the ZFS arc. It was designed way before that. And so various things have changed and customers are still returning to...
And it gives you those 4 columns of disk statistics, which are completely useless.
Yeah.
You know, nobody uses those. So yeah, it's a tool that's been around for decades, and it really needs an infusion.
Wait.io. You want to say a word on Wait.io?
That's a good thing. % Wait.io, we still get that, and that's not a problem.
We fixed all your Wait.io problems in Solaris 10. You will never have a Wait.io problem. Yeah, so it's hard.
So that is because basically CPUs, they're out in the CPU, what is it?
So it's grouped with the CPU statistics, and the problem basically is this: is that
stat, right?
Wait.io is not a legitimate CPU state. It's not. Threads wait for I/O. CPUs don't wait for I/O.
Yeah.
So to start with, how do customers see this? I think they see % Wait.io either through top or through SAR. I think those are the major concerns.
And well, they did see it in NP-stat until we hard-coded it in Solaris 10.
Yeah, that's right. So it's now hard-coded to 0 in Solaris, so % Wait.io is always 0.
Right.
That was leading to a lot of not a problem escalations. Customer says, I have a lot of Wait.io. It doesn't actually matter.
No, all that meant is that the last thread that ran on that CPU called BIO wait, and when that CPU went to look for more work to do, it didn't find any, so it accumulated a lot of BIO wait time. Okay. But the CPU doesn't wait for I/O, the thread was waiting for I/O. So.
And that's right, the CPU could do other work.
Absolutely,
and that Wait.io would go down.
Sure.
But it's not relative.
Yeah, it generated a lot of confusion. Customers would call thinking they had a disk I/O bottleneck because they had a lot of Wait.io.
From a 1980s analysis.
Exactly right.
Going to the 1980s with free memory, just historical perspective is somewhat interesting. We had Solaris 2.6 where actually free memory was running down to 0 and customers were complaining about that, right? And it turns out that memory was available, it was just held down in the file system caches.
Right.
So around Solaris 7, we kind of said, okay, so if you want to see memory that is consumed by file system caches as free memory, we're going to give you that. So from Solaris 7 on, if I recall, maybe Solaris 8.
It was around that
7 or 8.
The cyclic page cache work. Yeah.
Exactly. So now file systems started to report consumed cache, pages that were clean and not modified in the recent history as free memory, so they were immediately reclaimable by application native memory.
Yes.
And then ZFS came around, and ZFS changed a little bit the way file system use, not just a little bit.
No, not just a little bit.
Not just a little bit, quite extensively.
Yeah.
Changed the way they consume memory. And so now we're back into the state where caches are taken out of free memory and consumed by ZFS. But ZFS will, like I said, under memory pressure, return the memory to the application. Historically, or at the beginning of ZFS, people would not configure enough swap space, which swap reservation is required for the dance of pressure from application to ZFS and ZFS returning memory. For that to happen, let's say properly, we needed, people need to configure swap space around a ZFS running system.
Right.
I think you made a good point about how free memory and how it was calculated and whether it included caches or not. And we did document that in the Solaris Performance and Tools book because it changed from Solaris version to Solaris version. If you are watching this video, you may have an epiphany where you say, well, if there's all these problems with the tools and statistics, why don't you fix them or document them to make it easier for us? And so we have been documenting them. That's the Solaris Performance and Tools book. And we are taking a very good swing at fixing them as well. For example, the Oracle Sun Storage 7000 series that has analytics, which is a GUI-based monitoring tool, and we're only putting statistics in there that make sense. And we're making sure that they're not confusing, that they're well documented, that they matter. So there's a huge emphasis on latency at the protocol layer.
Right.
So we're definitely doing that. The two things that we need to do is...
You're put in context.
And it's put in context, you put it in context of the clients, the files that are being accessed, the shares. So yeah, the two things that we need to do is better documentation and produce better tools, which we're doing with analytics.
And the thing that people that are reporting performance problem needs to do better is putting their perspective into more measurable context, into business problems. What is it that they're facing? It's gonna make the dialogue smoother.
Yeah, so since you mentioned swap, it's probably a good time to mention my top 2 pet peeves, which is people who want to engage in, a 1-month engineering investigation as to how much swap I should configure. Because, back in the days of, of Sonos 4, we had the rule of thumb, right? 2 to 2.5 times memory, and everybody was basically okay with that, and they rolled with that, and we didn't have any problems with that. And then we changed the design very substantially in Sonos 5, Solaris. And with SwapFS, and then with the ability to configure a separate dump device for kernel core files, so you didn't need a swap device for that. People get very hung up on how much swap should I configure? And my answer to that question is almost without exception the same. We could spend a month, doing the research and measuring the virtual address space of your workload versus the physical address space of your workload, or you could just, go 1x memory up to 32 gig. If you have 32 to 64 gig, then go, 0.5 memory, and come up with a very, very simple rule of thumb. Why? Because it really, in the scheme of things, isn't just that important. Disks are cheap. If you've got a machine that has, 64, 128, 256 gig of RAM, which actually is getting more and more commonplace these days, then what you spent for that machine is going to be 100 times more than what you'll have to spend for a single disk that'll allow you to configure enough swap space where you don't have to worry about it, and you can invest your time in real important things, right? And that gets to issue number 2, which is optimizing my swap device for good IOPS, right?
Yeah.
If you're optimizing your swap device for IOPS, you're wasting your time. You're chasing a second order problem. Your machine is running really, really bad.
Yeah, these swap, those are really reservation that allows the memory management to work. We need to configure swap. We don't expect to be using any.
Yeah, exactly right. Yeah,
right.
It's like an insurance policy. You buy it, and in this case, you buy it via the cost of the disk that you use to configure it. And ideally, you're never going to use it.
Yeah, perfect.
Another not a problem example to bring up is open source benchmark tools, and I get a lot of these where customers say, I downloaded this open source benchmark tool.
Bonnie, whatever. IOZone.
I've run it, and there's a huge problem with my system, and there's not actually a problem with the system. There might be a problem with how they're interpreting the results. There might be a problem with the default workload that these tools are applying. Often these tools bear no relevance to what the workload the customer is actually running. And so that's why we try to steer them back to what actually matters to you. What is your workload that you care about? These tools are just pointing you in the wrong direction. Unless you can customize the tools to resemble your workload, be very cautious about it.
Yeah, that's a good point. And actually, I know that's a sweet spot of Roch's because we've been chasing this 20-page spreadsheet with IOZone results.
10,000 results.
10,000 results, and 2 of the cells are red. and we have to identify.
The customer won't migrate until all the cells are red.
But yeah. So that's the memory stuff, and I guess what that leaves is the network, which, in my experience, this is much less of a problem in terms of something that kind of comes across my desk as, hey, I'm getting this network metric, and I think it's a performance problem. And that, I think, has a lot to do with the fact that people tend, for whatever reason, and I don't know what this reason is, they tend to look at the network metrics last. They look at CPU first all the time. They run VM stat, so they get their memory picture. They run IO stat, and they see the disk IOPS. And for whatever reason, they tend to look at the network stuff.
I think that's partly because it's difficult. If I want to look at network port utilization on Solaris, if I use netstat -i, it's only giving me packet counts. I can't.
Can't get bandwidth.
I can't get bandwidth.
We need to integrate IO stat with.
No, we need to integrate NIC stat with Solaris.
Or IOStat, IOStat could look at a NIC.
Yeah, that's a good. I actually
as a disk device.
That's not a bad idea. I'm fond of the columns
Maybe
IOStat gives. So it's a good idea. I'm fond of the columns IS that gives, except for like read and write latency, but that could be applied to network ports. And you'd see the reads, writes, throughput.
Either or, but certainly, yeah, I mean, that's that.
But analytics in a 7,000 storage, you don't have these kinds of questions.
Yeah, that's right.
Because all these stats, as you said, are relevant. They're presented in a meaningful way.
But it gets,
and they're first order, so they're all at the same page. And when you say which stat do I want to look, they're all there. So you're not biased towards what you know. VM stat. You just look. Hey, this is it.
But it gets back to the point Brendan made early on, which is it's really all about what's inducing latency in the workload. And with network, it's no different. We have tools, dtrace. It's relatively easy to figure out how much time your threads are spending waiting on reads from the network or writes to the network, and thus tie that latency right back to the performance problem.
And maybe you wanted to talk about 10 gig networking in this segment. We could. In 10 gig networking, people are accustomed with up to 1 gigabit network interface. I mean, you put a client, you put your 1 gig interface, you're going to be able to saturate, get 100 megabytes per second fairly easily. Yeah. Now the world is migrating to 10 gig networking. It's a different kind of ball game. The single-threaded workload, by virtue of the CPU speed we have today, by virtue of the way device drivers are written on both the network, the client side and server side, do not saturate 10 gig networking that easily, right? So you
need lots of threads.
Yeah, this is a good point. I've dealt with a lot of these, and you're right, this is another not a problem escalation, where the customer says, I'm now testing 10 gig networking, but I'm not doing 10 gigabits a second. And they're testing it maybe with a single client and a single thread. And the thing you need to know is it's about setting expectations. It's hard to do 10 gigabit a second. It requires a lot of horsepower. We can do it on the Oracle Sun storage systems.
Right.
But if you've got some old client farm that you're using to perform a load, you may need to spend a lot of time tuning that.
Beware the switches.
Beware the switches as well.
The switches, they're 10 gig switches, but they might not be able to saturate a 10 gig link. And we've got the ability to have two 10 gig link up in the storage appliance.
And beware of the payload size that you're doing in your test. I mean, if you're testing 64 by 32 byte transfers. But you're interested in bandwidth, well, you're at odds there because this is packet rate, not bandwidth. So if you want to measure bandwidth, then you need to crank up your payload size, right?
And use jumbo frames to get good throughput.
Yeah. I mean, there's a couple interesting parallels between disk IOPS and network, right? I mean, with disk, it's IOPS, it's reads and writes per second, and the latency associated with that for most workloads. But then there's the bandwidth component, where some workloads don't care about IOPS, they care about bandwidth. I'm running a streaming video server, whatever. It's the same with networks. Some network loads care more about bandwidth. Most workloads care about packet rates and packet latency. Well, your point stands, Brendan, is, I started up, I grabbed UPerf, and I'm running a single client, a single server, and I'm only getting 1/10 of my gigabit, link bandwidth. Well, fire up 20 more threads, and you'll get to your,
In the Oracle Sun Storage appliance, we've got a lot of bandwidth available to us. So you really need it will serve your client farm, and you need to build a big client farm before, let's say, saturation sets in on the storage side.
Yep, that's right.
Okay. So I think that basically covers kind of the sort of high order, what we tend to run into in that initial couple hours or couple days of the customer performance escalation, some of the more common misconceptions around some of the metrics that we generate, and just some good advice about if you want to get through this problem, as efficiently as possible, then make your problem definition concise and clear. Make it a metric related to the workload that you're running, something that we can measure.
And latency helps as well, because latency that the client was waiting.
So that's it.
Thank you.
Okay.